All right, I'm just going to go through the answers now for set number 2, which looks like this. Starting with the easiest problem, number 1, I'll read it out first. On Shrove Tuesday, Joseph ate twice as many pancakes as Alicia at dinner time. Later, Alicia had another 3 pancakes. Altogether, they ate 18 pancakes. How many pancakes did Alicia eat? Okay, so the key piece of information there is altogether they ate 18. Okay, looking at the last part of the problem, it says that Alicia had another 3 pancakes after dinner. So the first thing that I'm going to do is go 18 take away 3, which, as you will know, equals 15. Okay, so that means together at dinner time, Joseph and Alicia ate 15. Okay, it says Joseph ate twice as many pancakes as Alicia, so that means he ate 2/3 of the pancakes. Alicia ate 1/3 of the 15 pancakes. So if I work that out, to work out 2/3 of 15, I would go 15 divided by 3, which is 5, times it by 2 is 10. So that means Joseph ate 10 pancakes, and then Alicia obviously ate half of that. She ate 5 at dinner time, plus remember, don't be tricked by the question. It says Alicia had another 3 pancakes after dinner, so 5 plus the 3 gives us our final answer of 8 pancakes. Okay, that's number 1. Moving on to problem number 2. Okay, it says Kim was born in the year 2000 and Jim was born 2 years later. In what year will their ages add up to 100? Okay, so what we need to work out there is, obviously with 2 years apart, we need 2 numbers that are only 2 apart from each other that will add up to 100. So that's a fairly easy question. Okay, if you were to take the number 40, for example, if you were doing guess and check, and if Kim was 40, then if Kim was 42 and Jim was 40, that would mean it would be 82 together. So obviously we need to go higher than that, and I'm pretty sure you will all come to the same conclusion as me. Those are the 2 numbers, 49 and 51, that will add up to 100. So the year that will happen is when Kim is 51 years old. So adding on 51 years to the 2000, your final answer will be 2051. All right, number 3. Gradually getting trickier. It says place the numbers 1 to 9 in the 9 empty boxes so that the arithmetic is correct along the 3 rows down the column. This is the diagram that we're referring to here. So I'm just going to quickly draw that letter E so that we can go through some strategies. Just bear with me a second. One, 2, 3, 4, 5. Okay, just about there. All right, I've got my diagram. Now I'm just going to put the symbols in. Okay, so diagram will look like this. This is, in terms of strategies, this is the classic guess and check strategy, which is normally the best way to work out problems such as this. So if we're looking at this one, it's not, remember, guess and check is not just a matter of putting random numbers in random spots. You have to actually use calculated guesses to ensure that you save time, because remember, in problem solving, it's not all about getting your answer, but also working out an efficient strategy to allow you to get to that answer quickly. So the two key pieces of information in this diagram are these ones here, the division sign and the multiplication sign. The reason why I say that they are key is because, for example, the multiplication sign, you're going to have two small numbers here, because remember, we're using the numbers 1 to 9, so the answer cannot be double figures. So the highest answer you could possibly get for this one would be 9. Okay, we couldn't use 9 because that would be 3 times 3, and we need to use each number once. Okay, so there's only a few different combinations. For example, 2 times 3, or I guess you could do 1 times something in there as well. But generally, the way that I started for this one is by playing around with numbers that were going to be low for this multiplication. Okay, and remembering if this one here, because division is going down, okay, this number will have to be low as well, and this one here is most likely to be high in order for the division problem to work. Okay, so I'll just play around with a few different combinations that I tried. Right, I actually got lucky on this one, and I got it pretty close to my first guess. So I'm just going to write down what I got firstly. So I started off going along the multiplication one. So I've put 2 times 3 equals 6. And then I can adjust that if things don't quite match up. Okay, next one I'm going to do is the division one down the side. So remembering that we're trying to use numbers that we haven't used. So that's what I mean about playing with combinations. So I've using the 2 here, I've figured that it has to be a big number up the top. So 8 divided by 2 equals 4. Knowing also that I had to use an even number up here, because if I used an odd number, it would mean dividing it by 2 would give me a decimal, and that wouldn't work for this either. Okay, so it means that we're reducing the possibilities here. Alright, so basing it off that, I can just use process of elimination to work out which numbers I haven't already used. And if we take away 7 at the top, or you could take away 1, I guess it doesn't really matter which way you do it. And then at the bottom, you're going to have 2 numbers to equal a high number. So 9 being our highest number there, that should be the answer that you have got. There are a couple of other numbers that you can have a different way around. For example, you could have 8 take away 1 equals 7 at the top, but that is still correct. All right, moving on to problem number 4. So now we're getting into the tricky stages. Remember, questions 4 and question 5 are always a little bit tougher. This question 4 says, using just $1 and $2 coins, how many different ways are there to pay an amount of $25? Okay, there are a couple of ways that you can do this, and I'm interested to know which strategy you guys used and how long potentially it took you. What I'm going to do is I'm going to work it out the long way, and then you can tell me if you have worked out a faster way to solve it. So looking at the amount of $25, what I'm going to do is I'm going to write down each of the combinations, and it follows a bit of a structured pattern after a while, so it becomes quite easy. So let's just start out with the first combination being 25 $1 coins. Okay, so 25 times 1, and then obviously if we've got 25 $1 coins, we're not using any $2 coins. Okay, note when I'm writing these combinations, I wouldn't now go 24 times 1, because if I had 24 $1 coins and $1 and one $2 coin, that would give us $26, and we're only after 25. So my next combination needs to be 23. I'm going down in 2s. So 23 ones, 1 times 2, okay. 23 times 1 is 23, and 1 times 2 is 2. Added together, that equals 25. You can see a pattern starting to emerge. So if I fill in one more, that will become even clearer. So going down in 2s, 21 times 1, and then 2 times 2. Again, that equals 25. You can see the pattern here. These numbers are going down by 2. These ones are increasing by 1. So I'm just going to fill in the gaps here. 19 times 1. And 3 times 2, 17 times 1, and 4 times 2, and you guys will start to get the drift. 15 times 1, 5 times 2. Just going to make it even faster. I'm just going to write down all the numbers on this side. 13, 11, 9, 7, 5, 3, and 1. And they're all times 1. And then on the other side, we are obviously going up and with an extra $2 coin each time. So that goes 6, 7, 8, 9, 10, 11, and 12. And they're all $2 coins. I'll show you exactly what I'm doing in just a moment. Okay, so that's written out all the combinations there. Okay, looking at the bottom one, just to double check, because it's always good to check to make sure that you are right. So for this one here, 1 times $1 coin is going to give us $1, and then 12 $2 coins will give us 24. Added together, they make 25. So that's perfect. I might grab a random other one to check. 9 times 1 is 9. 8 times 2 is 16. 9 plus 16 equals 25. So we're looking pretty good. All that's left to do is just count up the different combinations. So, tahi rua, toru, wha, rima, ono, whitu, waru, iwa, tikau, tikoma tahi, tikoma rua, tikoma toru, or 13. So your answer for that one should be 13 different combinations or 13 ways to make up $25 using $1 and $2 coins. Okay, lucky last, the toughest question of the set. Let's have a look at what it's asking us. For the rectangle shown, A is 1/3 of the way along the top, B is 3/4 of the way down the left side, and C is halfway down the right side. What fraction of the rectangle is shaded? Okay, we're looking at this diagram here. Okay, now the first thing that is going to help us solve that particular problem is knowing how to find the area of a triangle. Now, hopefully most of you will know how to do that. If you don't, I will refresh you with the formula. So remember, to find the area of a triangle, you would go half of the base times the height. Okay, half base times height will give you the area of any triangle. Now, the tricky part about that is making sure that you know what the height is. So if you were to look at this triangle here, okay, you can see because of the type of triangle it is, it's going to be really hard to find the exact height of that triangle. Okay, so because of that, we have to look at different ways to gather that information. Okay, now the way that I did this is I made it into a bit of a grid, so you can see how this diagram here is not in grid form. I thought it would be easier to try and get my head around it if I made it into a grid. Okay, so looking at the fractions that are used, we've got 1/3, we've got 3/4, and we have got half. Okay, so I need to make sure that my grid fits a common denominator for all of those. So it needs to be divisible by 3, by 4, and by 2. Okay, and because of that, I went about making a grid that was 6 by 4. And that's just the way that I did it, and I'll be really interested to know if you guys used a different method or a different size grid, because there is more than one way to solve this particular problem. Okay, I'm just forming my grid now so it's nice and clear for you guys. Okay, and 6 along that way. Okay. I wouldn't say that my grid is perfectly to scale, so I'm just going to tidy it up a little bit. 6. Okay, just about there. Right, so it's not exactly to scale, but roughly that's what a 6 by 4 grid will look like. So as you know, that will give us 24 squares in total. So when I work out the fractions here, I'm going to be using that as my base number. So now I'm going to go back to the problem just to make sure I've got all of the facts exactly right. So it says for the rectangle shown, A is 1/3 of the way along the top. Okay, and if we're making it 1/3 of the way along the top, there are 6 squares here. So that means 1/3 of that is going to be 2. So that's the dot for A. So you can see I've marked my dot for A up there. Okay, B is 3/4 of the way down the left side. So with there being 4 squares, that 3/4 of 4 is going to be 3. So I know instantly where to put my dot for B. Okay, you can see that there. And then C, it says is halfway down the right side. Obviously half of 4 is 2. So that makes it fairly easy for me to locate my 3 dots. Okay, now that I've got those 3 dots, I can join them together to make the triangle. Okay, and I'm just going to color that in to make that super clear. Right, nearly there. They are quite complex, these problem number 5s, so they do take a little bit more time than some of the other questions. All right, that's what my diagram looks like. Okay, so I've got clearly labeled my A, B, and C points, and you can see which parts are shaded. What I'm going to do is I'm just going to revisit the question again just to make sure that I know exactly what information I'm trying to find. So the final question says, what fraction of the rectangle is shaded? Okay, so straight away I can see that more than half of this rectangle is not shaded, so that I know that my fraction that is shaded has to be less than 1/2. So I know that straight away, that's in the back of my head, and will just help me to make sure I'm on the right track as we go about solving it. Okay, what I'm going to do next is I'm just going to have a look at the parts that I can work out the areas for, because I'm going to work out all of the areas of the non-shaded parts. Okay, you can see that this here is a triangle, that there is a triangle, this here is a triangle, and that's a rectangle. Now the good thing about that is that I've got 4 shapes that I am very confident of working out the areas for, and the reason being is because these are all right angled triangles. Okay, you can see that's the right angle there, that one there's right angle there, and this one's a right angle. Now with a right angled triangle, it means that you can easily find out what the height of the triangle is. So using this formula up here, half base times height, that will make it nice and easy to find out those 2 areas. And then obviously to work out the area of a rectangle, that's just base times height, so that's super easy. So we're going to work out the 4 areas of 1, 2, 3, and 4. Okay, and then work out what fraction of the total shape that is, because whatever the other fraction is will be the shaded area, and that will give us our answer. So I'm going to take the easiest one first. The bottom bit here, okay, it is 1, 2, 3, 4, 5, 6. Okay, you can see it's 6 across and 1 up. So to work out the area of that is easy. 1 times 6, okay, which equals 6. Remember, there are 24 total squares here, so 6 out of 24 is the same if you simplify that down as saying 1/4. So you can see that 1/4 of the grid is taken up by that rectangle there. Okay, now I'm just going to put some lines across that because we know that we've done that area. All right, we've worked out the area of that part at the bottom. Now we've just got those 3 triangles to go. Okay, we're going to take this one here, triangle at the top. Okay, remember it's half the base times the height. So you can see the height of this triangle is 1, 2, 3. Okay, and the base is 2. So half of that base is 1 times the 3. Nice and easy. Equals 3. Okay, so far we have worked out the areas of those 2 shapes. Okay, we've got 2 more triangles to go. Looking at this one here, okay, you can see that the height here, 1, 2, 3, 4. The height is 4 squares. The base again is 2. So half of that base will be 1 times the height, which is 4. Nice and easy. 1 times 4 equals 4. We are just about there. Okay, we've now worked out that triangle up the top, which leaves us only with one more triangle to work out the area of. Okay, the height 1, 2, 3, 4, 5, 6, and the base is 1, so that will go to 0.5 or half. Okay, half of 6 is 3, and we can shade that in. Okay, we've now got our full calculations here. 6, 4, 3, and 3. The next part that we need to do is to add all of those numbers together to work out how many of those squares out of the 24 are not shaded, which will help us for our final answer. So 6 plus 3 is 9, plus another 4 is 13, plus another 3 is 16. So we know that 16 squares are not shaded. And remember, putting that into a fraction, that's out of 24. Okay, now that's not our final answer, because like all fraction problems, we would want you to simplify that as much as possible. Okay, if we're simplifying, we're looking for a number that's divisible by the numerator and the denominator, the top and the bottom number of the fraction. So if we had a look at those two numbers, I'm going to give you guys a little bit of thinking time. Okay, hopefully you've come to the same conclusion as me. If we divide both of those by 8, so 16 divided by 8 is 2, 24 divided by 8 is 3, it becomes 2/3, and that's as simple as we can get it. Now, just to triple check with the question, it says what fraction of the rectangle is shaded, so we can see that 2/3 of the rectangle is not shaded, which would mean that the shaded part is 1/3. So our final answer for question number 5 is 1/3. If you guys have any questions about any of those answers, or you want to discuss any different strategies that you use, please post on your maths problem solving channel in your class team, and I will respond to any questions you have, and we can discuss any extra strategies. Other than that, I hope you enjoyed your problem solving challenge. There'll be another one that comes out next week on Monday. And same thing, you'll have the whole week to work them out. And I will post another video with the answers then. Have a good afternoon. See you later.